So fuel modifiers, transients. Now transients are accelerator pumps. They overcome sharp throttle openings. They enrich in fuel for to overcome dead spots and flat spots. What we recommend with transients is that they're turned off while you do the tuning, so you don't get any false readings on the dyno, and then turn them on and adjust for that. You don't want to be adjusting transients for a hole in the map, like if there's a lean spot in the map or something like that. So transients. Okay. So we can activate them on or off. So we're going to turn them on. We've got acceleration enrichment by load. Now, what this is this is our base starting figure. If we give it 400% fuel, that's 400% more fuel on top of the fuel map. We've got the next folder down, which is rate by RPM. Now, if I put in 100% there, that's 100% of the previous 400% of load. So this gives you some idea on how much we can actually put into the motor for blown sort of style engines. Acceleration rate by engine temp. So we can actually go in, once again, hit the X button, collapse this right down, and we can do something along the lines of so there we're going, okay, at 80 degrees engine temp, we're giving it 20% of our 100% of the 400%. So at the moment we're giving it 20% of fuel. All these parameters are individually adjustable. Our decay rate. Now this is how long do we want this shot of fuel to stay in the engine or in the intake system. So if I give it a decay rate of 50, then what that means is as we accelerate and we pump that fuel in, every time injector 1 happens, we're taking 50% of the fuel requirements that we're asking to give it and taking it off. So if we're giving it 400% more fuel, then we're going, okay, next injection that it happens, it'll be 200%. The next injection will be 100%. The next injection will be 50. So that's actually only going to be there for about 4 or 5 RPM. If I go and give it a decay rate of 2, then it's going to go, okay, we've got 400% of fuel, we're taking 2% off it. So that now we're down to 390 odd percent. And it's going to take about 50 to 100 RPM to decay that rate of fuel. Now, that can be very effective if you've got a big throttle opening, 8 throttle bodies. You need to have a long duration of accelerator pump. That will overcome that. In your load scenario, this 0 to 107% load is in reference to this load point here. So you can, once again, you can bring the scaling right down, and you could make something like this happen, right? Where at an idle or a cruise, we're giving it a lot of fuel, up under 30 pound of boost where it doesn't need it. It's not doesn't need the accelerator pumps. You can take the accelerator pumps out. The rate by RPM, once again, that's self-explanatory. We can increase and decrease in regards to what RPM we're doing. Now, we may find that we have a slight stumble as we get off the line, so we give it a little bit of fuel like that off the line, and then we find that, you know, after 2000 RPM it's fine. So we can actually increase the transients on that. This can also be seen in the aspect of if you watch the enrichment point here, I explained that in another video, that's showing you the enrichment. If I accelerate really quickly, you can see how slow that's counting back. Right, and if I change my decay rate, so if I make that decay rate 70, and we'll do the same thing, and you'll see that the enrichment decays very quick.